Hey everybody, it's Marty the JavaScript Party. My buddy Rhett. I have her a nut. Let's see what she really seems to want it this morning. So here you go, sweetheart. Oh man, so it's Monday morning, 7:33 a.m. 72 degrees outside, but I bet it feels like 90 or close to 90. It was very hot out there. Um, so click here. 73. Well, feels like 81. Okay, so yeah, I guess I just don't feel very well. I did not feel well at all over the weekend. Um, and then yeah, 96% humidity. And basically my youngest child, my younger son, he he was like grumpy and tired and had a headache on Thursday and Friday. And then he felt better by Friday night. And then I was a little tired on Friday, which is not unusual, right? I mean, like you put in a good hard week's work and you're going to be tired. And then, like I did a little bit of drinking on Friday night, and then, but not really a lot. I thought it must have been a lot because I just sort of blacked out around midnight, and because my son said he saw me going back to the bedroom around midnight, and then did not wake up till 11 the next day. And I slept just rock solid till 11. So 11 hours. And then I was just like, man, what happened last night? And then I was very surprised to see, because I was like, oh, jeez, I must have just like went crazy drinking. But no, there was still a lot of alcohol in my bottle. So I don't know what the heck happened, but I was definitely sick all day Saturday. Felt a little bit better Saturday night. Felt a little better than that on Sunday morning. Then we went out and sort of just ran errands, and I didn't feel good. I still don't feel great, but now my wife, she started to feel sick yesterday, and then now she doesn't feel good at all. Um, so we got some sort of little 48-hour virus kind of thing, um, which is kind of a bummer. But anyways, so and then of course at that same time I went into probably what's likely to be one of the very most confusing parts of this application. And basically what happened was once I added the ability to delete, a lot of like, I don't know, I guess what you call them is foundational behaviors that I was able to this is so weird. Forge your destiny. Avowed premium edition. I don't even know what that is. Um like a lot of foundational things just kind of fell apart because now like basically I could sort of lean on indexes of arrays. Like, okay, this is third, so it definitely came after the second, blah, 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 blah. Well, that's no longer the case. Now that you can delete things, you could delete like the first, second, and third one, have a fourth one, then add a fifth one, and now the fifth one is newer than the fourth one, and things get weird. And so we went through and just kind of fixed all the places where I was sort of going by index and not going by uh, actual, physical position. And I think I've gotten to the point where where it's like um, time to do something that's I don't have a whole lot of experience with and is very challenging. And that's like to determine what the next place something should be in. Like basically determine if it's occupied or not. And if it is occupied, then go get another place to go get it. And this is still easier than like right now, since all we can do is create and delete. That means we don't have different sizes and things. Like things are going to get a lot more complicated once we can have different sizes and things and stuff like that. But right now they're all 200 by 200. So we can move forward in this. But so if you want to see what the issue is, basically what you do is you add a viz, add another viz. Uh-oh. Oh no. Well, so we have another issue. Okay, so they're all broken. Um, so that's kind of a bummer. I don't think that's where we were. I didn't think I Okay, so when we add our second viz, it ends up just right on top of the first one. So we've completely broken whatever it was that was determining the position. And I think it's like I added this manual placement. So if it's not, once it's been manually placed, but the problem is that I guess something in here is happening. So inspect. So we're looking at, and that happens a lot. Like a lot of times what will happen is like you start to fix things and then it gets more broken first. So number 2. So we only end up in number 2 twice, which makes sense, right? So if I hit refresh here and I add a viz, and then I add a second viz, so we end up in here again, and it's like at this point it should have figured out, oh, there's already someone in, there's already a viz in step 1 in the 1, so I need to add 200 to it, but for some reason it didn't. All right, so, and I think it's good that it only gets in here once, because it should really only be setting. The problem is that um, it's not getting the, so we are just hard coding this left to 0, and then it's supposed to, I don't know, needs row, it's going off of this, and then yeah, so that is like if it's too wide, but then like the previous right is never being set. So the previous right, it shouldn't be previous right, it should be like next available right. And that's probably, yeah, this is gonna get tricky. So basically we wanna figure out what the next available right is and the next available top is. I'm just gonna leave that there for now, but let next available, and I guess we wanna find the top first, top. Okay, and then I'm just gonna call that 0 for now, and I'm gonna put a comment that says, okay, figure out if the rows are full. And then if they are, find the next one. So basically, our goal on this line of code is to figure out if the row is full. And if it is, then give it another row. And then let next available left. And I'm going to set that to 0. And this thing's job is, based on that row, figure out if the first 200 is available, if the second 200 is available. Okay. Once we have a row, figure out which column is available. And I guess what that is doing to me is mentally is saying, hey, I need to break this thing up into a grid, 200 by 200 tall, and then I need to figure out how many and that is not going to be like long-term sustainable solution, because these won't all be 200 by 200 in the future. But for now, that's good enough, and we're going to have to go through another sort of mind-bending situation like this in the future to figure these things out. But so, 1, find out if the row is full. And okay, so let's just create a function called get next available top. So I would say at this point I'm in full creative mode. Like I have no freaking experience or idea how to do this. So I'm just like creating something from nothing at this point. Um, I did do this once before. I made this little video game that I really enjoyed playing. Um, I made a video game, and is that a colon or a semicolon? Um, and then and there was this library, I believe it was called SAT, and you could pass it 2 coordinates, and then it would tell you if there was a collision, if there was any overlap. And I'll probably need something like that. I probably won't. I'll just write it myself. Um, but basically, what we want to figure out is if our current row is full. If the current row, so equals 0. So we want to know if the 0th row is full. And if it is, then we want to add 200 and check to see if the next row is full. Or is, so all we want to know is like what's in there, and is it as wide as, would it accommodate another item? Okay. Let's return current row, return current row. All right, now the question is, can the current row accommodate a new visualization? All right, so basically if I pass, so I need another function that says is row full, which I'll pass a number to. All right. So, and we are really honestly just spitballing here, like just trying to make up the thing. But I do think that this is like one of the most interesting things in UI development is how do you deal with like grids and figuring out overlap and stuff like that. And I just don't have a whole lot of experience with that. I do have some. I have enough experience to know how difficult the job is. And yeah, sometimes I guess that might even be the worst place to be. Sometimes just being like naive makes it a lot more fun. But this is a challenge that I've had to deal with before, that I've struggled with before, and this is kind of the whole point of this whole exercise. All right, so is row full? And then I'm going to call it current row. And I'm going to say that's a number. And I'm going to return a boolean. I'm just going to say return true. And really false is the, and then let full equals false. And we're going to return full. All right, so now I want to call it, right? So get next available top. So basically we are going to want to loop until it's till the available top is found. Right, so let's see. So basically, I'm going to while loop. Anytime I create a while loop, and it's very rare, I only create while loops once every couple of years. Um, but anytime I create a while loop, I always, while I'm in development process, I always create like an escape valve, um, because getting caught up in freaking infinite loops sucks. So let found escape equals 0. And then basically I'm going to say while not found. And this is something that, like, while loops like this back in the 90s, wrote them every single day. And then, I don't know, everyone just moved away from them. But if you're actually looking for something over and over again, it is kind of nice to have a while loop. I think what happened was there's another concept where a function just calls itself and just keeps calling itself over and over again until it finds the answer. I think that became very, very popular. And when that, the need for while loops sort of went away. Um, so I believe you can just say break and break out of a. Okay. So basically, I'm going to say found escape is equal to found escape plus 1. So this code will never make it, should never, ever, ever, ever make it to production. This is purely development code. But I'm going to say if found escape is greater than 1,000. So obviously we are not going to go 1,000 rows down. We shouldn't go there. So and then basically, so if we go through this 1,000 times, which should be so much more than even conceivable, like 6 times should probably be the most it should be. Alert. Breaking out of infinite loop. All right, so basically what should happen here is I should keep calling and looping until it gets to 1,000, and then it should be alert, and then I should be out of it, and the current row that it's going to respond with is 0, and this top should be current row. I'm just going to leave everything as is though. It's equal to row. Oh, so I'm using this already. Oh, next available top. Yeah, I'm just gonna leave everything as is. Doesn't look like I'm calling it though. Get next available top. Hi there, Rhett. This dot get next available top, which should just be 0, and I guess that's the same as this and this dot get next available top. Oh, these morning phone calls. Top. And so there's that, and now what I want to see, what I think I would see is when I add something, I'll get my alert. So, yeah, because it did that as, oh no. Why did it go twice, I wonder? So we got in there twice, apparently. So for each, so for some reason, I guess the set calculated position got set. And oh, and I guess we're calling this up here. So should we get, I guess we shouldn't get the next available top until if the manual placement is set to false. Only if it's set to false. Once it gets set, and manual placement might not be the right word for this. Yeah, we shouldn't be calculating that every time. Hello. So now what I'm expecting to see is that it only happens once. Nope. Oh, silly rabbit. We call it twice. Hello. And maybe that even makes sense just to do it there. So the way these are set up is not helpful. So let's tab that in. That's a little bit more, less confusing. All right. And I don't think we will. Yeah. Yeah, so all of this is going to go away. So let's go ahead and comment that out for the moment. And let's just see if we just get our one. Okay. Everything's working as we were hoping. I had a bad, I had a couple of bad assumptions in my head. And then if I had continued to work down that, I got those straightened out by just making sure everything works right. And if I had continued to go down that road, I would have built on a bad conceptual situation. And then everything would have got way, way more confusing. It is easy just to keep pushing forward, saying, okay, that's some small detail, I'll worry about that later. That's an easy route to take, but it's probably a mistake. Now we're getting we're calling this, and then we're just getting 0, and we're breaking out of it. And so now this guy is basically going to take that number and see if there, well, I guess first thing we'll see is there anything even on that row? And this is where we kind of slip from rows, the concept of rows, to the concept of positions. So are there any other things? We know for a fact if we go through the existing visualizations and we don't find if we don't find any visualizations, then it's definitely not full. And then so this will be the first thing we do is say const is current row full. And we are going to call this dot is row full. And we are going to pass it our current row. And our first, and I think it should be found is equal to that, right? Found is equal. So if it returns a false, I guess this should be is row empty. So that this reads right. Empty. Oh, no, available. Not empty, available. And then available, by default, available is true. And then we return available. And basically, we do a loop over our this dot. I think it's get visualizations, right? What do we look at over here? Yeah, visualizations. Oof, we may not even have. I wonder if we even have access to that. This is row available. Cool. And then we're going to probably have some scoping issues that we're going to have to deal with. So basically, we're going to want to loop over all of these, which we really can't loop through them at this point. I think these are visualizations, right? ST visualizations. Yeah, ST visualization. And basically what we're trying to do is determine if it's too wide. Okay, well, first one, determine if there's anything even in the row. And then two, if there is, determine if there is a spot where it can fit. Right, which that's going to get complicated. But right now we don't even have any visualizations when we first call this, so okay, so to do this, we're going to say I think we want to do a const found in row equal to viz dot stTop is equal to current row. All right, so if we find anything, then we did find it in the row. And then we return available. Okay, so this isn't going to be quite enough to do this, and we're like, it's hard, you know, because I really want to focus, like deep focus at this ground level, just determining if there's something in the row, but it's hard to not like the way we test it. We have to kind of test it by running through everything. But right now, I'm just kind of testing just to see if anything is. What am I trying to say? I'm just trying to just see if things work the way I expect them to work. So, and I guess the best way to do that would be to alert found. So the first time I shouldn't find anything. I guess I'll just do console found, comma found. All right, so this is, so now we're just gonna kind of think, okay, what I want, at first I should never find anything on the very first row. I should get my alert, and let's just, I guess, console log. Change this from an alert to a console log. And let's just make it, this is the serious one. So found will return true right off the bat. So we should, the very first time, there should be absolutely nothing in there. We will find it immediately. Um, so we should never break out or anything like that. At least. And found is true. Now, is that right? Okay, because we found an available row. Is row available? Yes. Found was true. We defaulted it to false. And then we found the right one. Now, the next time, okay, so I guess now we would actually, so before we wouldn't even get in here. Um, so so we won't even get in here the first time because we won't even have a visualization to loop over. The second time, we should find something in the row. And I guess what we're going to do is, if we find something in a row, we still need to check to see if there's still room in that row. Which is, yeah, so that gets a little bit more complicated. Because then we got to figure out what the width is, and we got to figure out if there's a spot in there. Like, is the first spot taken? Are there any spots in there available? All right. So found is true. Boom. Found in row was true. So now, wait, so that's wrong. This found, how did we even? Okay, something seems weird, right? Because how did we even get in there to begin with? That's what's weird. It's like, I didn't think we'd even get into that. Oh, because I guess it already exists. There's a timing issue here because, yeah, the actual ST exists. So it did find it in the row. But this is it. Oh, that's interesting. Okay, so this so all it did was find itself. And that's right, because we're looping over ourself here. So we need to find out if there's anything that isn't ourself, right? So what I need to do is, so that's an edge case. The edge case is, hey, like if I find myself, then I will find myself. So when we pass this get next available top, we need to pass ourself in there. And if you're sensing that, like, I don't actually know what I'm doing at this point, you're sensing exactly right. And that is like, it would be nice if when you're coding, you always knew exactly what you were going to do, but it's just not the way it is. Um, Sometimes you just have to figure stuff out. And sometimes you don't even know enough to even formulate the right words so that you can go to like ChatGPT and say, hey, can you build this for me? Because I just don't even know, it's like, this is just so exotic and foreign for me that I don't really know exactly what to do. So current row, and then viz. And then, oops, wrong one. Wrong place. Okay, so first of all, one, we'll add a new one. This will be 2, 3. Ignore self. Right, so basically we are not going to do anything if the viz if current viz dot st render id is equal to viz dot, oh my gosh, viz dot I don't know why you'd have a double not, but I guess that's what you normally see. Control X, Control V, and then, so we only want to do this if it's found in the row. So again, I had a misconception. It's easy to do, right? There's just a lot of things going on. And this is moving super slow, but it's because I don't want to build on misconceptions. And because I'm aware of how little I understand what I'm currently trying to work on. And because this is something I'm very, very desperate to understand better, is like collisions and things like that, understanding where overlaps happen. Okay, so then see, this is the one, I think, 242. Yep. And another one in current So now we have figured out that there's another one in the row. So now we got to figure out, okay, is there room for another one? And basically we're I guess, and I think I did something like is too wide. See, I have the left plus. So basically what we need to do is, okay, so we know the viewport width. We need to get the all of the segments and add them together, and all that. So um, and I don't know if we, so that is kind of one way to do it. The other way we could do it is we could just keep looping over until we get to the width. So like, I guess one thing that might make sense is to create an array of all of the visualizations that are in that row. That's probably the next step. Okay, so row siblings. Is equal to T say this is a const. Okay, and when we for loop, the second thing, and you just have to remember this, index is the index. And then the third thing is the list. And so basically we want to go through the current list and we want to make a map from that. And in this map, basically we just want all of the visualizations that we're just going to return if mapviz dot st_top is equal to current row. All right. So basically we want every single one. Did I do that wrong? I did that wrong, I guess. Oh, that's right. That's probably the best I've ever done, though, right off the bat. Normally I struggle with this. So if that is the case, then return mapped viz. right? No. Did I do this right? Let's put this on another line. Okay, so what's it complaining about now? Oh, didn't do a return. All right, so maybe this mapping doesn't work the way. I've always really struggled with the map one. Mapped viz. Okay, so this time I'm always returning it, but I don't want to always return it. I only want to return it if the mapped viz has st top is equal to that. So my understanding is I can do this, right? I can go oh my gosh. Why can't I? Okay, so let me put this into ChatGPT. Okay, so is st top is equal to 0. Oh, filter. I want filter, not map. Okay, that's good. I just grew. I just hated this, all these little, whatever these things are called. These functions that when it first came out, I just hated them so bad. And now, but they're great. They're absolutely great. But I just had a very bad feeling for them at first. I just didn't like them. And now I like them. But since I came at it with such a bad attitude to begin with. Top is equal to current row. So this should get me all of the columns. Okay, console log, and then it's row siblings. Const row siblings. All right. So the very first time we should get just the one. Okay, so the very first time we should get nothing because it's by itself, and it will only work on that. And I guess it will, yeah, it will, oh, okay, so it won't run it if it's the current one. So, so the first time we should see nothing, right? We didn't, well, nothing is not, but we shouldn't see like the row siblings. But the second time we should see the row siblings. So this is interesting because I thought there would be one in here. I'm a little confused at why. That filter didn't work. All right, so let's redo this. We shouldn't get in there, I don't think. The very first time we shouldn't even get to the break position. Second time. Now, so let's see if there's anything in current list. Well, let's just try to run this whole function. Okay, so I didn't find any. Just current viz list. Okay, current viz list has that. Did I call it st top? And so this is the main thing I don't like about like not having the full all the code in here is like, because you can't really debug into there. It's harder, or it's a lot harder to debug into there. Okay, so let's come back over here and go to right there. No, it was visualization service. Let's see if we ever even get in here. No, we have to be getting in there because it's definitely testing it, but for some reason it's not finding. So the first time we shouldn't get in there. The second time we should. Current viz list is these things. And now we want to be in here because st top should be 0. Current row should be 0. Oh, I did an assignment, not a comparison. Notice there's only one equal sign. And I don't even do a return. I would have yeah, it was weird. I don't know what you would expect to see in there. Inspect. Row siblings. Okay, so it found both of them. Now, it found itself, which it probably should ignore itself, but and I guess we should just, it'll probably be easier just to get rid of it. Okay, so we only return them if it's this, and then we'll put some parentheses around this, and we'll put an and mapped viz dot st render it is not equal to current viz dot st render id. All right, so now what we expect is just once we've done two, just to find the one. So all we're trying to do at this point is find out find out if this row is full or not. And we won't be able to, we'll kind of have to put a pin in it on this and then come back after we can actually set them, because they're all just being placed right on top of each other. So the row won't ever be full at this point. And then row. And so row siblings is just the one, and it's sitting at a width of 200 and all that. So it looks like we have all the information we need, but all this thing needed to do was, well, okay, so now we want to loop over all of these in our rows, right? So we want to loop over and see if in our current row siblings, if it will accommodate, if we can add another row. Is it full? So we want to make sure that, so like full would be the width, right? If there are viz items from 0 to viewport width full. And then we have other issues like, let's say we have 100 gap, a width of 100, like, then does it fit, things like that. But I think those will be easier to deal with once we can actually make the changes. Okay, so what we need to know now is, what is the viewport width? And we really only want to do this, I guess we only want to do this stuff if there are row siblings. Greater than 0. Because in the future, and again, I never know exactly what you should do in the future when the future comes, and then what you should set up ahead of time. But in the future, we could have one visualization that takes up the whole row. So we only want to do this. We don't want to do this processing if there aren't any siblings. If there are siblings, then available is true. And then so it's called this dot viz width, or this dot viewport width. And then I guess what we need to do is try to find the total width of those, but of all the siblings. And I guess, I guess there's an array operator that will just calculate things like that. I find that to be much harder to use than just like for looping over it. Um, but I guess we would maybe the start and find the far left, and then the end is the far right. And if the end plus the current width is greater than, so we would have like a false positive, right? Like if we had one all the way to the left and one all the way to the right, we could end up with a false positive, because we'll say that the row's full even though there's two available spots in there. I don't know if we care about that edge case or not. Um, but if we do, I think it'll be easier to fix once we have it than to try to do it. Um, okay, so const start. And that is equal to the farthest left. And then I guess we'll probably also have negative things, that are off screen. So then, yeah, that's going to be another interesting list end is equal to 0. And that's going to be the farthest right. And then I guess we'll just do this to do. Let's see, it's 8:35. So this is hard. I think that it's going to be like much more difficult. Well, okay, so I think right now we're writing a bunch of really ugly code, right? Like code that would never ever fly in a professional environment. But this is what happens, like when you're just trying to figure stuff out. And the thing is like for me, it seems like all like because of ChatGPT and all these other tools, the really the only like so there are job openings for like technical people that are like connected, like their parents were the business or whatever, and so like they get all the tasks. People like that get all the sort of known like how to do. It's known how to do it. There's a known way to do things. There's a right way and a wrong way, and the right way is known way, and that's how you do it. But then there's also gonna always be work for like something that you're sort of inventing from scratch, and that's kind of what we're doing here. And the thing that's nice about that is you don't really have to be connected. You can, that's a pure meritocracy sort of situation, because like if you can't do it, you just can't do it. And there's no, it doesn't matter who you're related to, or you know what your background is. It's like some people can and some people can't, and this is the part where a lot of people just can't do it. um, the part where you just have to sort of invent something out of nothing, and that's what we're trying to do right now. So basically, I think what I could do is I could have a function that I pass these four row siblings into, and it figures out what the farthest left version of it is. And right now, we're making a bad assumption that we're that the farthest left is 0, and that is not always going to be the case. Okay. Um, but I can tell you I really feel confidently that if we figure out how to deal with, if we try to figure out how to deal with start positions that are less than 0, we're going to end up over 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 engineering a solution. Um, and it could just be so simple, or it could be a real pain in the butt. Just no telling. Okay, so I'm going to create a function called get farthest left. Get farthest left. And this is going to accept our array of visualizations. We'll just call it row siblings. And these are potential row siblings, I guess. And it's going to return a number. And basically what we're going to do is I guess let left equals, I don't know, we'll just come up with some crazy number like one, like that. And then return left. And then what we're going to do is we're just going to iterate over every row sibling. And there probably is a way to do this with, I think that's called the reduction operator. That one I've always really struggled with. And then we're basically going to say if viz dot st left is less than left. So the first time it should definitely be less than whatever that is, 100 million or whatever that. Then left is equal to viz st left. And this should get us whatever the smallest one is. And I guess even this will even handle negative numbers. So I guess that's good. And so we're going to return left. Start get farthest. And this thing is going to be so hard to unit test, I think. Console log, the farthest left is start. Okay, so what we're expecting to do is see 0 as our most leftward. And what we're still trying to do is figure out, is it too wide? And so what we're going to want to take is the most rightward right spot and add the width to it and then see if that's wider than the viewport width. And if it's not, then I guess we'll look for the next, I guess that is the left spot. And I don't even remember how all the stuff above us works, so like how it all fits together. I'm completely fixated on this level of understanding. And it is a scary situation because I know that there's other things up top and I might be going down a path that doesn't work, but like I just can't encapsulate all of that into my brain at the moment. Okay, so we didn't do anything because there was nothing to solve. And then what we want to see is the most leftward is 0. Our viewport width is 982. All right, so now we're going to be looking for the farthest right spot, farthest right, which that will set to 0 and add to. Now, let's say our farthest right is 0. That's fine. I don't see any reason to not say 0 is our farthest right spot. No, ST. Okay, so we have to calculate the right spot. Position is equal to viz st left plus viz width. St width. So that is the rightmost spot position of this. So if this right position is greater than right, then right is equal to right position. Man, I hope this stuff works. Right. All right. So now, do I console log that? Am I console logging it? Right. Siblings. Rightward. So this is without a doubt like the most frustrating, but also the most rewarding and the most fun sort of coding, I think. But I'm literally 999 hours out of 1,000 hours that I've ever spent coding in this sort of deep level coding. I've done it heads down, one merge with the code and with the computer, not in this sort of interactive vocabulary way where I have to try to put it in words. And then the second one, so we're hoping that the most right will be 200. And it wasn't. What did we do wrong? So I don't understand why that didn't work. Let's see, most rightward. Oh, well. Yeah, I don't really understand. I guess I have that. Printing out the row siblings afterwards. Okay, so this is the problem, right? This guy right here. So let's try it again. And then, all right, get farthest right. Step into that. Okay, right is 0. Right siblings. Doom, doom. Oh. Oh, okay, that's where it found itself? No. that's weird. Let's try it again. Step into that one. I guess I should have one right there. Row siblings is something. But it looks like we're not getting there. Did we have a console error? Okay, there we are. ST left is 0. ST width is 200. If right position... Oh, I have that backwards. Right position is... It's if right position is greater than right. Silly rabbit. I'm getting tired. I don't actually feel great today. I definitely feel way better than I did yesterday or the day before. But I definitely am not at the top of my game at the moment. All right. So let's try this again. Inspect. Add. Console log. Run. Okay, most right word is 200. Okay, so then I guess the next thing is, what is the next potential? Const. Okay, candidate. Left candidate. And that is going to be end, right? And then const candidate width. I think it's ID. Width. Oh, candidate, right candidate. Is equal to end plus current viz dot st width. Man, we are gonna once I have to get this working for unit tests, woo, we are in for a good one. Okay, so now what we want is the right so if the right candidate is greater than this viewport width, then this is not a good row. Current row. And available is equal to false. Right, so basically that row, we sent in a row of 0 and it's all full. Whatever is on the far right is wider than that. Now the problem is that the way this code is we'll never get to an unavailable one. Now next we'll have to say, oh, okay, so it is available. It'll be true, and then set the next one in, and then it's true, set the next one in, it's true, set the next one in, and then false. I think we can only get 4 across, maybe 5 across. And then we can come back here and finish the code for multi-rows. And this is one time where I'm really glad we have the end-to-end test, because we know exactly how it's supposed to work. And we have tests that are supposed to test it, because that end-to-end test is broken now. The one that does the positioning, that's completely broken. So 853. Inspect. So basically, we can never test that. We can't test the code that we just created. But I think we got as far as we can get. Um, because now we know that the row is available. And it's going to return the current row. And then once we have the current row, that is the next available top. So that's 0. Is row available? Turn that true. Yeah, and then basically the next thing will be to get the next available left. So basically this function that we're using well, it looks like we're going to want to break this out into its own function because row siblings is an important piece of functionality. So so basically we need to get this. Okay, this needs getting siblings. A row is important. Important. Its own functions. And then definitely getting the end is super important because this is what, okay. Okay, so it's already its own, so I don't even need to worry about that. But yeah, so getting the row siblings, so then I can pass that to this thing, and then it'll be easy to figure out what the next appropriate right position is. And or the next appropriate left position is actually the get the farthest right. That is actually the right position that we will go into. So, and like I said, I'm really glad actually now that I think about it that we got that end-to-end test working. So, anyways, it's 8:56, so I got to go to work. It's Monday. I think if I'm guessing, my boss probably got my PR, one of my PRs, at least maybe even multiple PRs, um, reviewed. So I'll probably have to dive into that. And that is, for me, the most challenging part of being a software developer is managing PRs. It can be very, very frustrating. And it's just because you're trying to communicate at very, very, very complex things. Um, so, you know, just that communication process. And it's a very asynchronous communication scheme. So things can get very, very confusing. And you never know what the mindset of the person that's going to be reading your responses and things like that is going to be when they come back across it. So it's tough. It's a very difficult task. Anyways, happy coding, everybody. Have a great week. Bye.